So just to pick up from where Paul left off, I'm first going to describe some of the testing and research that the ICC TWB Ad Hoc Committee considered when developing the mass timber code provisions. Early on, the TWB recognized that it would undoubtedly need testing to validate its proposals. The Fire Work Group, which is a subset of that committee, it's one of those 4 work groups that Paul just mentioned a few slides back. They developed test scenarios, including the physical layout of the test structure, the configurations, and the fuel load. The test structure represented a multi-story condominium or apartment building in which each unit had interior dimensions of 30 feet by 30 feet. So it was basically a square, but there were multiple rooms within each apartment. And we'll show you a floor plan in a minute. There was also a corridor and a stair shaft within the test structure at each level. The fuel load was based on a North American study of fuel loading for residential use groups. In fact, to ensure rigorous test conditions, furnishings and other combustible contents were added to achieve a fuel load that was equivalent to the mean plus 1 standard deviation. So the actual fuel load used within the test structure corresponded to approximately the 85th percentile of residential fuel loads when compared to that survey. The expressed purpose of the test series was to evaluate occupant egress tenability, firefighter attack tenability, also to assess systems response to fire, such as the sprinkler systems and other systems within the like fire penetration fire stops and so on and so forth. And then, of course, most importantly, to guide code development. The series, which consisted of 5 separate fire tests, was conducted at the ATF Fire Research Laboratory, and it was supervised by Forest Products Laboratory staff and administered by the Forest Products Laboratory staff. The photo on this slide here on the lower right shows the CLT test structure in which these fire tests were performed. It was all 5 of the tests were performed in the same test structure. Of course, there were some rehabilitations that were performed between each test in order to repair any damage to such as the the non-combustible protection and so on and so forth. But yeah, all 5 of the tests were performed in this same structure. By the way, that's the same structure that Paul showed a photo of as an example of how big CLT panels can be. So this is the apartment or condo floor plan that was selected by the fire work group for the 5 tests. There was one 900 square foot apartment on each level of the test structure with a corridor leading to a stair shaft on each level. So you can see that these fire tests were truly full scale. It was a full-size apartment or condo on each level. The TWB Ad Hoc Committee insisted that the construction must be compliant with the current IBC, as well as with all of the proposed code changes that were being developed simultaneously. To achieve this, 20-minute rated entry doors were installed on the apartments, and 90-minute doors were used on the stair shaft to separate the stair shaft from the corridors. The corridor was instrumented to determine firefighter tenability and occupant egress tenability within this egress route. So the scenario represented by the first 3 tests was a highly unlikely one in which you have basically an unlikely overlap of 2 scenarios. The first part being that the automatic sprinklers fail to activate, and then the second part simultaneously being that the fire service does not respond at all to suppress the fire throughout the entire duration of the fire. So basically, we're looking at the realm of where those 2 scenarios overlap, which makes it even less likely. In test 4, the automatic sprinklers were allowed to activate on their own. So this represented a typical scenario, since these tall mass timber buildings are required to have sprinklers. Notice I said tall mass timber buildings are required to have sprinklers. Obviously, as as Paul will show later on, there are cases where mass timber buildings can be designed without sprinklers. However, they can't be tall then. They're limited to very low, relatively low heights then. So all tall mass timber buildings will have sprinklers. And then test 5 was an unusual test condition. I'll get to that one on the next slide. And of course, what I'm talking about here is all dealing with the TWB work product and the prescriptive provisions that they developed. They're going to go into the 2021 IBC. I'm not talking about any potential performance-based designs or alternate means and methods or anything like that. So this is the test matrix for the individual tests within this series. Test 1 served as a baseline to establish the performance of fully protected mass timber. This fully protected configuration represents type 4A construction. And that's what they had envisioned at that point as type 4A. It became known as that later on, actually, but at any rate, that's test 1 is equivalent to what's now recognized as type 4A. And then test 2 was an investigation of partially exposed mass timber on the ceiling, representing maximum allowable exposure in type 4B construction. Test 3 was an investigation of exposed mass timber on the walls, again representing the maximum area exposed allowed in type 4B. So test 2 and 3 were type 4 or representative of type 4B. Like I said a minute ago, test 4 looked at sprinkler effectiveness in mass timber construction. It was the shortest lived test. Within about 6 minutes, the sprinklers had effectively extinguished the fire. Test 5 was an investigation of the ability of a manually charged sprinkler system, which is initially incapacitated for some reason, to help control the fully developed fire. In order to simulate this scenario, the water supply to the sprinkler system was initially shut off, and then it was manually charged 23 minutes after the fire started. This simulated a scenario in which the fire service hooks up a water line at the fire department connection upon their arrival at the scene. All 5 of these tests were performed in the same test structure. The first 3 tests were carried out for 3 and 4 hours and until the fires had effectively burned out due to lack of remaining combustible contents. The other 2 tests, tests 4 and 5, were much shorter because the sprinklers suppressed the fires before the contents could be consumed. A good portion of the fuel load was achieved through a combination of the typical residential furnishings. You can see them in these pictures here. Combustible floor coverings, which you can see here. OSB was used just because it's cheaper, but that actually has a higher fuel load than a lot of typical combustible fuel coverings anyway, or floor coverings anyway. And then cabinetry, which you can see back in the kitchen there, and other combustible contents. Even with all of these furnishings and contents, it was still necessary to add additional fuel load in order to achieve the relatively high TWB specified fuel load. As I mentioned earlier, the specified fuel load was 1 standard deviation higher or above average for Group R occupancies. So in order to get up to this required level of fuel load, wood cribs were also added to the test structure for each test. And the fuel load was the same for all 5 tests. So you can see there's a wood crib that was placed on the coffee table, a wood crib placed on this this piece of furniture right here. There were quite a few wood cribs you can't actually see because they're in the background, and also in the bedroom there were quite a few. There's some furnishings in the bedroom that that you can't see because of the angle of this photo on the right here. There was a desk and a chair there, and a couple of pieces of furniture on either side of the desk as well. So this doesn't show all of it, but it shows the majority of the combustible contents. These still shot photos of test 1 show conditions at key stages during the fire growth and decay phase. By the way, the term decay phase simply refers to the stage in which the fire intensity is diminishing due to a reduction in available contents. namely because most of those combustible contents have already been consumed at this point. So that's why the fire is decreasing in intensity during the decay phase. The photo in the upper left shows what it looked like shortly after ignition. The living room reached flashover at about 12.5 minutes after ignition, and the bedroom reached flashover at about 17 minutes. The peak heat release rate of this fire was more than 20 megawatts, and that was the case for all three of the first three tests, which were allowed to burn unhindered and which were supplied with enough combustion air. As I mentioned, it was allowed to burn without intervention or automatic suppression. So this was the case with all three of the first three tests. The bottom center and bottom right photos show the condition of the living room and bedroom following the test. Note that all of the combustible contents and the unrated partitions are gone. You can barely see the unrated partitions on this. There'll be better photos showing the unrated partition later on, but the mass timber structural elements are essentially unaffected. The mass timber elements also did not become involved or contribute to the fire. In test 2, 30% of the CLT ceiling areas in both the living room and the bedroom were left exposed. This amounted to 20% of the overall ceiling area or overall floor area of the total apartment. And again, that's the well, we'll talk about. I'll show a slide that actually has an excerpt later on of the language, the code language, which specifies these exposed area limits. But 20% is the limit for the ceiling area. So this basically maxed out the allowable exposed ceiling area for type 4B. And that's shown in these two photos here. You can see that exposed area. This is just in the living room. There is an equal area exposed also on the ceiling in the bedroom. And then the photo on the left here shows water barrels that were placed on the roof of the test structure on top of the floor ceiling assembly in order to load that assembly during the test. I didn't show a video of fire test 1 because we only have time to show one brief video here in this presentation. So I chose to show fire test 2 because this one has some exposed areas, again, on the ceiling. You can see in a few of these panes the exposed areas. And then in these panes down here, you can see the men that are in firefighting apparel igniting the fire. And you can see it was ignited in the lower kitchen cabinet. Same place it was ignited the same way and in the same place for each of the 5 tests for repeatability purposes. And I'm going to go ahead and fast forward here a little bit until you'll see it spreading, especially as I fast forward here. And it's spreading onto the combustible floor covering there. And then I'll fast forward to flashover, which, as I said, occurred at about 12 and a half minutes. And that's right about here. So there's flashover of the, notice flashover has only occurred now in the left portion there. That's where the living room and kitchen are. Again, the ignition was in the kitchen cabinet, so that makes sense. And then if you look over here in this pane, this is a shot of the bedroom, same with this. And you can see the flames and smoke starting to come into the bedroom. The bedroom door was left open, as were all of the interior doors, in order to allow for the fire to spread unhindered. However, the self-closing 20-minute rated entry door into each of the apartments was left closed for each of these tests, except for one test, which I'll explain later. But for each of these first 3 tests, that self-closing door was left closed because it would be closed since it's self-closing. Now we're approaching flashover in the bedroom, which occurred about 5 minutes, or yeah, about 4.5 or 5 minutes after flashover occurred in the living room and kitchen. And that's it just occurred there. You saw the bed start to flash there. And in this screen, you can see the plumes coming out of both openings now, both from the bedroom and from the living room and kitchen. So this is what they'd call the fully developed phase here. This is a fully developed fire throughout the entire floor plan of the apartment. Now I'm going to fast forward, and as the combustible contents are consumed, you can see the intensity of the fire diminishing. This is the decay phase that I referred to earlier. And for the latter half of the test, it continues to decrease in intensity until at about 4 hours. This test was carried out to 4 hours just to make sure that there were no flare-ups or fire regrowth or anything like that. And there wasn't. And so it had pretty much self-extinguished. You can see a little bit of smoldering over here in the bedroom at the end of the 4 hours. That was just some remaining combustible contents. I think they were books from books that were put into a bookshelf there in the bedroom. Here are the still shots of some of the key events during and after test 2. The living room reached flashover at about 12.5 minutes, like I said, and then the bedroom was about 17 minutes, reached flashover at about 17 minutes. The fire was allowed to proceed for 4 hours, by which time the exposed mass timber had already self-extinguished. Notice that the protective layer of char had formed on the exposed portions of the mass timber ceiling. You can see that both on the living room ceiling and the bedroom ceiling here in these two lower right photos. Here's a post-test photo that was taken after the gypsum was removed from the ceiling after test 2. In this photo, you can see not only the post-fire condition of the CLT, but also that of the glulam columns and beams. The areas protected with gypsum wallboard were uncharred, with the exception of minor localized surface charring at the lower edges of the glulam beam. You can see that here. The exposed area of the ceiling can be seen here as the charred rectangular area to the upper right of the man on the yellow ladder there. And this photo shows a sample cross-section which was cut out of the exposed portion of the CLT ceiling following test 2. On this sample, the char has been scraped off in order to more clearly show the depth of the char. As you can see, the char was not quite 1 lamination thick. So these laminations were 1 3/8 inch thick. So that means this char depth was between 1 and 1 1/4 inches here. And the reason a portion of the lower lamination was not charred, this part right here, is because this portion of the CLT ceiling was protected. It was protected by either the gypsum wallboard or the trim work that formed the border between the protected areas and the unprotected areas. So this is good. This is a good cross section because it actually shows the transition between the protected areas and the unprotected areas following the fire. In test number 3, wall B was exposed in the living room and wall D was exposed in the bedroom. This layout shows the location of these exposed walls. Notice I say the wall D was exposed in the bedroom and wall B was exposed in the living room. I say that, I qualify it by saying in the bedroom and in the living room because the exposed portions of walls D and B went from approximately here to about right here. The walls were not exposed in the bathroom or in the kitchen. So, and then same with wall B, the exposed portion went from about right here where the living room starts to where it intersects wall A. That amounted to about 40% of the total wall area. The center wall separating the bedroom from the living room was light gauge steel. It was constructed with light gauge steel infill between the glulam columns, and it had 1/2 inch unrated gypsum board on each side. This wall didn't need to be fire resistance rated because the loads were carried by the glulam columns and beam, which were fire resistance rated. So as expected, the center wall quickly disappeared during the fire test, leaving only the mass timber walls and columns and beams. And of course, they still retain their load carrying ability. In test 3, where about 40% of the CLT walls were exposed, flashover times were about the same as in the first 2 tests. Again, the fire was allowed to progress without intervention all the way to burnout. And unfortunately, the last photo here we have from test 3 doesn't show the very end of the test. This shows about halfway through the fire test, and you can still see some burning there because there were still some combustible contents left. In test 4, all of the mass timber surfaces were exposed in the bedroom and living room, and the automatic sprinkler system was allowed to activate normally, which it did at about 2.5 minutes after ignition. Within 6 minutes, the fire was effectively extinguished by the sprinkler system. It probably would have been extinguished even sooner if it weren't for the fact that the cabinet shielded the fire from direct sprinkler impingement. Remember that the ignition point was under the cabinet, under the lower kitchen cabinet in each of these tests. But the fire didn't spread beyond the lower kitchen cabinet, and this is the sum total of the damage that occurred in test 4. Just like for test 4, in test 5, all mass timber surfaces were fully exposed in both the bedroom and the living room. The sprinklers were purposefully prevented from discharging in test 5, though, and then they were manually charged 20 minutes after the time at which the sprinklers automatically activated in test 4. This simulated a scenario in which the sprinklers fail to activate automatically, but are then manually charged by the fire department connection, or at the fire department connection by the fire service upon their arrival at the scene. Flashover conditions were reached in the kitchen, and the bedroom was very near reaching flashover, although it didn't quite reach flashover, but it was definitely reached in the kitchen. Within 7 minutes of manual charging of the sprinklers, the fire went from a fully developed fire, which can be seen here in the upper photo, to being effectively suppressed, as you can see in this lower photo here. So that was just a 7-minute period between that and that. As you can see in this summary table for all 5 of the ATF tests, flashover in the living room was fairly consistent at around 12 or 13 minutes after ignition. And the time to flashover in the bedroom for all 3 of the first 3 tests was also even more consistent, actually, at about 17 to 17.5 minutes. And this is despite the differences in exposed mass timber areas between these first 3 tests. The time that it took for flames to breach the 20-minute rated door into the hallway was about 27 minutes in test 1 and 30 minutes or 31 minutes in test 2. In test 3, the flaming on the backside of the door of the 20-minute rated door occurred early because the door was not installed correctly, but in any event, the flames did not spread beyond the door within the corridor. And that's evident in the videos of all 3 of these first 3 tests. The Research Institute of Sweden, or RISE, R-I-S-E, used their model to predict the behavior of ATF tests 1 through 3 before they were even performed. The measured data from the actual fire test closely matched predicted values. For example, in this graph, the solid black line is the predicted rate of heat release rate for test 2, and and then the blue line is the plot of data collected at ATF for this same test, for test 2. Based on this, it was concluded that it is possible to accurately model the fire performance of mass timber structures. The full report that details the results of this test series was published by the U.S. Forest Products Laboratory in 2018. and it's available on their website at this address here, or you can just go onto the FPL website and just do a search for GTR 247. All of the tests and videos were recorded also, and these videos are also available for free public viewing, either at regular speed or the time-lapse versions like the one that we watched of test 2. These time-lapse versions are available on the AWC, the link, you can get to them through a link on the AWC webpage, specifically the Tall Mast Timber webpage on the AWC website.